Okay, so now we are going to look into business applications of neural network and other things. Now, when it comes to business applications, we have taken certain examples in different business contexts, and then we will see that how it can be done. One example that is taken here is that how we go about risk management. Okay, like when a bank is going to grant you a loan for different purposes. So, you know that when the bank is granting loan, many times you find that people are defaulting and not paying their loan at all, or there are times when they become defaulters. Okay. So, it becomes a liability for the bank. So, suppose they want to mitigate the effect risk and see that there is a reduced risk when they are going to disperse loan applications. So, if you are going to use this network, neural network, then you have to see that in what way we can proceed. So, one example that I have taken here is risk examples, where we are going to evaluate commercial loan applications. In this case, suppose you find that okay, number of people who have applied for loan, some of them were approved and some of them were not approved, right. So, it means that there are two categories that you have created now, loans that have been approved and loans which have not been approved. Okay. And this is based on what? The judgment and the experience of certain procedures or rules that have been followed by the bank employees or the bank people in approving or rejecting the loan applications. Right. So, from there, once you have got this, then you also see that those who have been accepted for granting loan, how many of them are going to default at later stage. Okay. Now, which is going to create a risk, because if you look at this, a loan default means that it is a bad loan, right. So, even if it is approved and you are not able to pay, since they have made these guesses estimations based on certain criteria and you have been granted loan. So, but still there is a risk because you have defaulted on paying the loan, right. So, you can find out that what needs to be done. Okay. So, you are going to use these neural networks, see that what is the percentage of defaulters even after approval of the loan. Okay. Then you can further go that okay, what are the factors which are responsible, what is their weightage. Okay. And then what kind of decisions you are going to take based on that, when you are going to take the next round of loan application. So, these are basically business decisions which can be used, like suppose you know that because of the changes in the political and economic situation, another application that is there when you want to predict that how much fluctuations are going to be there in the foreign exchange. You know, the foreign exchange fluctuations is based upon the economy of a particular country. For example, if you look at the rupees and if you convert into dollar, you know that the rupee value keep on changing. Okay. Sometimes it is 68 rupees, sometimes 65 rupees. So, there is a fluctuation in the market so far as foreign exchange is concerned. So, what you are going to do? You are going to see that what are the factors or inputs that could be used as a predictor of fluctuations. So, they are going to act as a input variable, right. Then you are going to develop a system, see that how the exchange rate works, and then you are going to put this data, right, and see that what is happening, that how much fluctuation is happening. Okay. And then you can see that okay, because of these foreign exchange fluctuations, how much you are earning or how much you are losing, right. So, there are a lot of applications of these neural networks in different cases. Another example that I have taken here is mortgage applications, right. You can also use this data in mortgage applications. For example, somebody is going to buy a home. So, what you do in the name of mortgage, you take the registry, right. Unless they pay the entire loan, you are not going to return the registration paper and these kind of things, right. And so, before mortgaging, what you do, you are going to take certain decisions based on what? Okay. Number of factors. Okay. Maybe the city, what is the property of the value, what is the market value actually, what is the circle rates, okay, what are the immediate neighborhood, because all these factors are going to decide about the price of the value, right. So, based on these variables or inputs, you can develop a system, okay, and then you are going to infer certain things from the data, and you can also calculate the risk that is associated with giving loans, right. So, there are different applications that can be taken up. Now, another issue is that how it fits with the knowledge management system. Since it is more objective data that you get, and you are going to use sophisticated statistical tools for the purpose, okay, These neural networks basically are related with high accuracy and response speeds, because if the data is correct, then you get better results, correct results, and the response speed is response speed means that the results come very fast, because you have already programmed it into software, and then you just put the data into the software and you get the results, right. And the data is, if the data is accurate, then you get correct results out of it, right. So you have input pre-processed data, that is very important. For example, you need data on all inputs which are going to put it in the equation, or those variables which is to be processed for the output, right. So that is the first stage, and then you have to see that all of them are going to be put in the equation at the same time, because you are not looking into one particular factor, but all the factors all together. So you must start all over with every new application. For each application, you are going to run the program, okay, to see whether the loan application is to be rejected or accepted, right. Now, but the most critical factor is that what is the level of knowledge that is associated with the input. It is not the technology which is important, but it is the level of knowledge which is associated with each input, right, which is going to give you the result, right. For example, if you go for case based reasoning, you use high level of knowledge, so you get fast result, but if you are using expert or rule based knowledge, solutions are slow, right. So you have to see that the input variables in a neural network are very correct, the high level of knowledge is associated, so that when that is put into the program or statistical rules, it gives you better results. We will also discuss some rules here, like association rules. How are you going to associate say these inputs with the output, like when you are going to mortgage loan applications, you are going to consider certain input variables based on which you are going to decide the property of the value of the property, right. So you are going to use a set of rules to understand the relationship which is going to exist in the data, right, and it is very important for you to understand these rules. Most common rule is Boolean rules, okay. If a rule consists of examining the presence or absence of item, it is a Boolean rule, whether it is required or not. So for example, if you have identified 6 input variables, whether all the 6 input variables are important or only some of them are important. So you need to identify those critical variables which are going to predict, okay, and you can even leave out those which are insignificant and does not critically relate to the output, right. One example that is given here, it is a very simple example, that if a customer buys a PC and a 14 monitor, then he is going to buy a printer, right. So what is the input? That PC and 14, and based on what you are going to predict, buying a printer, that is a behavior, right. So you have made a rule that if this is happening, then this will happen, right. A person has a PC and a computer and a monitor, then there is a likely that he is going to have a printer. Now you can add other rules also. For example, if he is a PC with a monitor and also has internet connection, okay, then he is likely to buy a printer. So you can identify these rules, and if you think that if these rules are available, and then you are going to see that, okay, these items are there, and this is going to be considered, and these rules are not going to follow, then it is not going to be considered, right. Then quantitative rules, right. We basically look into the quantitative value of the items. For example, if you think that a customer earns between 40,000 and 50,000 and owns an apartment worth between say 15 lakhs to 25 lakhs, then he is going to buy a car, okay. So this is a more quantitative approach compared to what we have talked about earlier, that is association. Okay, if you have a PC, you need a printer, right. So you are going to associate PC with the printer. Now here what you are going to do, it is not simply absence or presence of a particular item, but you are going to see that how they can be related. So you say that, okay, if you are earning is this much, then you are likely to buy a car. So as a seller, I am going to approach you, because if you fall in this category, then you are going to be a potential buyer, right. Now there could be a single dimensional rule, because you are going to look into one attribute, or you can also have more attributes at different levels, right. For example, you are living in a big city and more than 35,000, then you are going to buy a phone, right. So this rule involves 3 attributes: living, that is you are living in a big city. If you are not living in a small city, they are not going to buy it. Then earning, If your earning is more than 35,000, then you are going to buy it, right, and then you are going to do it. So, this is a multidimensional rule. Now, in the multidimensional rule, you are going to have multi-level association. So, different level of association. Now, look at this example. You are looking for electronic devices, that is the first level of abstraction. Then second level of abstraction, electronic devices could be PC, printers and monitors, right. Now, in computers there are two options that you can have. Then you move to another level of abstractions, that whether you are going to buy a personal computer, whether you are going to buy a laptop. Now, printer again you are going to have two options, that whether you are going to buy inkjet printers or whether you are going to buy a laser printer, right. Then monitor, whether you are going to buy a 15-inch or below or above 15-inch or 17-inch and above, right. So, these you can even categorize it at different level of abstractions. So, it becomes easy for you to decide. So, for example, he needs an electronic device, he is going for a computer, that could be a PC, and he is looking for a laser printer, and because he has a 17-inch monitor, right. You can further go for it. For example, if you have internet connection, okay, whether he has internet connection or do not have internet connection. So, that kind of abstraction has to be put in either the first level or the second level, right. So, then you go at the fourth level of abstraction also, right. So, based on that you are going to associate whether the person is going to buy certain things or not. So, when you are going to take a decision, you make certain rules, and if you classify, you are classified within that rule, then you are going to do it, otherwise not. So, these are the association rules, like. So, look at this, there are four things that is to be considered. It has four elements, right. When a customer buys a PC, in 70% of the cases he or she will buy a printer. It happens in all 14% of all purchases. This means that an association rule consists of four elements. These are the four elements that we need to consider. First is rule body, that is when you are going to buy a PC, that is must. This is the first condition of the rule. Then you have a confidence level, and that is that in 70% of the cases it is likely that they are going to buy it, right. In 30% cases it is not going to happen. Then result of the rule, that whether he is going to buy or not. So, that is 14%, right. But this is to be supported. This result rule head is going to be supported, that how often items in the rule body occur together as a percentage of the total transaction. So, the result is 14%, right, and that is how we are going to associate. So, there are four elements which are very important, that is rule body, confidence level, rule head and support in an association rule. Now, another thing is market based applications. In market based applications, what happens? You create scenarios. So, one example that I have taken here is a US company, that is Petco. What they have done, they have basically used business analytics data basically, and used geographical information system, and they basically whenever they want to locate a new store, okay, they want to open a new store. So, they have lot of factors to see that the store is going to be profitable or not. So, and what kind of risk is associated with that one. So, they have used these rule based systems. Okay. Now, what they do basically, they have software called ESRI, GIS based site selection solution, which actually help them to mitigate the risk associated with networks of stores. Now, see, the risk increases as you increase the number of stores. It also depends upon, okay, whether your what is your location of a new store, okay, because if your location of store does not have potential buyers, okay, then it is not going to mitigate the risk, right. So, they basically they use these kind of analysis to assess their sales potential for the new locations and what are the risks associated with this one, and that is how they were able to successfully decide about the locations, and the confidence level is very high because they use this kind of data to identify, and based on that they have been able to identify at least 1200 locations nationwide, and they have been working successfully. Now, apart from market based analysis, we also use classification trees. Okay. These are very powerful tools for predictions. Okay. And here rules are explained to people to understand, or a database is created to see that records fall whether in this category or that category. Okay. So, basically this concept of tree has been derived from the graph theory, and tree is nothing but a network of nodes which are connected by areas called branches to avoid loops in the network. So, each node is connected, and that is known as branches, and there is a root node, starting node and then ending node, and are called leaf nodes, right. and this roof and leaf nodes are separated by intermediate node organizations are called layers. So, you can have different layers. Now, if you look at this example, you can see this is level 1, this is layer 2, this is layer 3 and this is layer 4, right, and there are different variables. Based on that you are going to take certain decisions, right. The average the income is one variable, 0 or 1.4, so you gone for this. Then education, whether it is 2.5 or this. So, there are certain variables based on that, and then we are going to look at the other variable, family, what is the family income, then here income is okay, what is the average income, and based on that what you are going to do, see tree, this is a tree that we have formed, then the root node, starting node, ending node, this is the starting node, this is the ending node. Now, what we have, then we have root leaf and root and leaf nodes are separated by intermediate node organizations. See, if you look at intermediate node organizations, that these are intermediate node organizations which have been made there, and then they are called leaf nodes. Okay. So, that is how we develop a tree. This is also known as tree or decision trees. Now, let us take some examples like a classification task, that how we go about classifying activities. For example, based on certain rules you can see whether a particular tumor is benzene or malignant, right. So, you are going to take decisions, and if the person falls in that particular category based on the records, okay, then you can say that the person has a tumor or the tumor is benzene. So, they need not worry, or it is malignant, and then this needs to be taken care, right. For example, you can classify credit card transactions whether they are legitimate or fraud, right. Then you can also classify protein structures based on certain things, or you can classify stores as finance, weather, entertainment stores, right. For example, news channels have different categories of information, right. So, this is how the the tasks are classified, and then you based on this you are going to develop classification trees, okay, and classify or predict an outcome based on a set of predictors. So, you have these predictors, and based on these predictors you are going to look at the outcome, right. For example, you here if you look at this, and the rule is that if income and education and family, then whether it is going to be accepted or not accepted, right, will accept credit card offer or will not accept. So, this decision to accept or not accept is based on certain predictors, and these predictors are income, education and class, right. So, you are going to collect based on this data on this, and you make certain judgments that okay, if the income is above this, education is above this, the family size is this, they belong to a particular class, then you are going to offer them credit card or you are not going to offer them credit card. So, this is basically known as the decision trees or trees, okay, and the rules are represented by diagrams. Now, I am giving one example of a decision tree here that you can look at. For example, you see this, okay, these are the things, see categories, okay, whether the refunds are made or not, right. This is the marital status, this is the taxable income, and whether they have cheated or not cheated, right. So, splitting attributes are refund, that is the first one. So, refund is no or yes, that you can see, refunded no, refund is there no, and then you look at the marital status, this is related to marital status. Now, in marital status whether you are single or divorced, okay. If you are married you are not going to consider, then you are going to see that whether tax, what is the taxable income, is it less than 80,000 or more than 80,000, okay, and then again you have no and yes. So, this is what we know as a decision tree, right, and this decision tree is based on this data, which could be different set of data, because you have categories data, you have continuous data, because this is a continuous variable, this is a nominal variable, this is also a nominal variable, and this is also a nominal variable class data, okay, whether you have done it or not done it. Another example you can see here, based on the same thing, this, what you have done, you have changed the attributes, right. Here first of all you have gone for marital status, single or divorced, right, different yes or no, then taxable income yes or no, right, and then you are going to see what is happening, right. So, you are going to make this decision tree, and this decision tree basically helps you to see that what is happening and who is doing what, right. So, based on this you can see that who are the people who are cheating, right. For example, you can see yes, those who are divorced have taxable income of 80,000 and above, right, 95,000 and above, or those are single having income of this, are single but have not made a refund, okay, but the income is 90,000, yes, they have cheated. So you can identify, say, okay. So based on that you can classify them into, okay, these are the people who have cheated and these are the people who have not cheated, right. And then your business decisions would be based on that, whether you are going to offer them credit card or not offer them credit card, right. So basically based on this data that you have, okay, you are going to use them certain algorithm rules, okay, in the model, and then you are going to apply this model. It means that you are going to deduct certain things out of it based on this data set, okay. So you are using these attributes 1, 2, 3, okay, for example, and then based on that you develop a decision tree and then you deduct certain thing out of it, that is the output, okay. So here you are going to index certain so you are going to have a learning model and here you are going to apply it, and then based on that you have a model and which is going to help you to take a decision with what is to be done, right. Now look at another example. This is the test data, okay, which we have got. Refund, no. Marital status, yes. Married. Taxable income is this, whether he is going to cheat or not. Now how are going to look at it? Start from the root of the tree. Refund, no. Marital status, yes. Married, no. Taxable income, that is 80,000 or above. So what you do, see how the tree has been made. So based on that you can take decision whether this person is going to cheat or not. So the likelihood that this person is not going to cheat, right. Now how this data is going to fit into this? Look at another example. You have these attributes, yes, no, and these are for the different kind of size, large attributes, large, medium and small. These are the income, these are the classes, right. Based on that can we take a decision? Look at this. So who is going to cheat? Which class of people? Attribute 1, no. So what you need to do, you need to develop a decision tree and then you are going to see whether they are going to be classified as a cheater or not a cheater, right. So based on this data you form a decision tree and then you can see whether he is going to be a cheater or not a cheater, right. Thank you.